Keith Bryant. Welcome back. I'm here with my great friend Mike Konrad, and we're going to talk about his tech talks, webinars, and all such associated things. So, let me start with the obvious question that I've been told I have to ask. How was the last webinar?
Well, funny you should ask that, Keith. We do a monthly webinar series that we call Tech Tuesdays. We get into cleaning-related topics, so cleaning best practices, cleanliness quantification, all that. And every year, I do the same one around this time of year, and it's on the subject of the new IPC J-STD0001 H and the changes in how we assess cleanliness. And it was probably one of the most insightful, best standards IPC has ever produced, for reasons I'll get into. But nobody likes it. In fact, there is a lot of negative energy out there. Why? Well, what do engineers want when it comes to a standard? Give me a number. Tell me what number I need to be at. We'll complain how unfair that number is, but at the end of the day, we'll get to that number. Well, we had a number 50 years ago. This number came out, and all of a sudden that number turned out to be like it should never have been there in the first place because it didn't ask enough questions. Yep. It applied the same number for you, for me, and you could be shooting stuff into space and I'm putting stuff in flea collars, and we had the same cleanliness number. So they changed it, and they changed it to more an objective standard. So your number could be anything as long as you can prove it works. And my number could be anything as long as I can prove it works through objective evidence. So I teach that course every year, and it just amazes me, quite literally hundreds of people who sign up for that. It just gets bigger. The more I teach, maybe I'm a bad teacher, because the more I teach, the bigger the classes get, right? So I don't know if I'm just not making it clear or if more and more people are going, okay, it's safe to ask the question, right? I think that's what it is.
And I guess the one that I'll ask you, which is maybe the hardest one, is can you explain what objective evidence really means? Because that's like one of the keys to the standard.
Yeah, it's ironic. It's a world of ironies, because ironically, to test if your board is clean, we don't test your board. We can't, because the method of testing that IPC's gone with is surface insulation resistance testing, SIR testing, under a stress condition, so under heat and humidity to simulate a harsh environment. The whole goal is to either make the board fail or pass after 168 hours of this grueling test under an electrical bias. So you do that on a test coupon, not on your real board. You do it on a test coupon that's kind of like your board. You reflow it with materials that you plan on using on your board. You put components on it very similar to your board, but it's not your board. So then, if that board passes SIR after 168 hours, now we have to take a picture of what that board looks like through a ROSE tester, resistivity of solvent extract tester. Basically, how contaminated is the board from a ionic contamination standpoint. We take a picture of that. And that number with the ROSE tester is now your upper control limit, your process monitoring limit. So one time, and one time only, unless you make changes, you do an SIR test, you commit to that. After that, as long as you don't make any major changes to your process, then all you have to do is ROSE test your actual production board once a day, once an hour, once a batch, every board, whatever frequency you think is best, and do it that way. So it's a great standard, because instead of saying, okay, here's a number that's objective, that's subjective, everyone needs to meet it. Now it's like, just prove it works. And we can argue whether SIR is the best solution for that. It seems to be pretty well accepted. The problem is most people don't do SIR in-house. They send that out to a lab. Yep. And if you're an OEM with 100 products, or if you're a CM with 1,000 products, are you going to take each one of those and send it out for SIR? Yeah. That can get pricey. So I think that's where a lot of the resistance is coming from. A little bit of understanding it, and then a lot of the realization once you understand it that it could be expensive. Yeah. But the whole idea is to make sure your boards don't fail.
Yeah, and okay, to pick up on the whole idea is to make sure your boards don't fail. Myself and a few other people are saying, why not test your board?
Right.
Because at the end of the day, you're going to throw it away anyway, but it's only one board.
Well, you can't.
You get a more accurate.
You can't do an SIR test on a typical production board, because you don't have comb patterns underneath BTCs. You don't have all the right traces to attach the probes. So test boards are designed usually with an edge connector or some other place you can connect wires to it. What is a good idea starting over, this would be all new designs, is put a little witness coupon on your side of your board that break away or depanelize, and have that be an SIR pattern.
Yeah.
And because right now, a lot of people with the rose testers say, oh, rose testers are no good, da, da, da. Rose testers are really good and not really good, depending. They do have shortfalls, but they're the only test that actually measures your production board before you send it out in the cold, cruel world, right? So you can't just rely on a facsimile. At some point, your board needs to be tested, right? To make sure the process that you set up 2 years ago on a good, nice, warm day when everything was working perfectly is still in order. So rose testing is fast. It takes like 2 minutes. It's been in the business for more than 50 years. It's well understood. It has its limitations, but it's kind of the best of what we got. And IPC is reluctant to change that part of it because there are thousands of these units in the field. We have 5 decades of documented history on the performance of those machines compared to reliability. So to adopt something new would be throwing all that valuable 5 decades of data out, right? So I think it's a brilliant standard that is just being met with questions and pushback from a pricing standpoint.
Yeah, and probably also a bit with a lack of understanding. But one last question. Okay, if you change your solder paste, you change your circuit board supplier, your circuit board finish, then obviously you've got to do it again. But what about if you up-issue the board and you go from a load of BGAs to a load of BTCs, for instance, where you've got low standoffs and a lot of other hassles?
IPC has what they call level 1 and level 2 changes. Level 1 changes are big changes, obvious big changes. Level 2 changes are surprising. And the amount of requalification or revalidation one needs to do depends on whether it's categorized as a level 1 or a level 2 change. Level 1 I won't talk about because that's obvious stuff. Changes in component types, changes in board designs, things like that. Level 2 changes that still require some re-SIRing could be you moved from line 1 to line 2. Same brands of machines on line 1 and line 2, but if you move it from line 1 to line 2, that's a level 2 change.
Wow.
You got to go back to the SIR table, at least to some degree. If you move it, if you keep it in the same line and you replace your machine for an identical machine, level 2. If, obviously minor changes in profiles, if they exceed the manufacturer's recommendation for your product, level 2 change. Surprising things like that. But the whole idea is, if it's going to fail, we want it to fail in the factory. As inconvenient and potentially expensive this process of validation, objective evidence can be, admittedly, what's more expensive? A recall?
It's still the lower cost option of the two.
Right, particularly high reliability. I mean, it could be more than a recall.
Oh, yeah.
Could be. You could be on the news.
Could be life critical or mission critical.
Absolutely. And when 60 Minutes shows up to your lobby, wants to speak to the president, they're not there to hand you an award.
No,
right?
It's not where you want to be.
No.
Okay, so well, thank you very, very much for. I'm getting the call that I have to shut up. So
all right.
We've obviously talked too much, but thank you very much for coming in.
Unusual for us too.
Yeah, very unusual.
Take care.
Thanks, mate.
Thanks.